more on limits. Today what we're going to look at is we're going to find limits using algebra, specifically when direct substitution fails. Let's just call it using algebra. Okay, so in the first case, alright, we're going to do the limit as x approaches 1 of x cubed minus 1 over x minus 1. Well, if I try direct substitution here, I've got 1 minus 1 over 1 minus 1. That is 0, which is actually classified as indeterminate. 0 over 0, which is indeterminate. Meaning I couldn't find anything, so I have to go back and try again. In this case, we're going to try factoring. So, if y'all remember sock and dock, alright, we're going to have to factor our top. So the limit as x approaches 1 of x cubed minus 1 over x minus 1 can become, now again, I always have to rewrite my limit part until I plug in my 1. So we're going to say the limit as x approaches 1 of x minus 1 times x squared plus x plus 1. Now if you can't remember how to factor those, go back and look at your factoring notes from the beginning of the year, over x minus 1. Well look, my x minus 1 and my x minus 1 cancels. So now I am left with the limit as x approaches 1 of x squared plus x plus 1. So now let's plug in 1. Now I no longer have to write my limit. We're just going to say 1 squared plus 1 plus 1. Well, that is 3. And that is my limit. Now this specific type of canceling indicates a hole in the graph. When I cancel it like that, on top and bottom, it means there is a hole in the graph. Okay? We're going to try one more. And again, this time it is the limit as x approaches negative 3 of x squared plus x minus 6 over x plus 3. Well, I plug in a negative 3 there. I know I'm going to get 0 on bottom. So we're just going to go ahead and assume it's indeterminate. We're going to factor the top and the bottom. So rewrite my limit. X approaches negative 3. Now, look at my x squared plus x minus 6. How can I factor that? I can factor that into x minus 2 and x plus 3 over x plus 3. What cancels? My x plus 3's. Now, let's plug in negative 3. So now we have the limit as x approaches negative 3 of just x minus 2. Plug in negative 3. I no longer have to write my limit. Limit my negative 3 minus 2 is negative 5. That is my answer. That is the value of my limit. Okay? Now, the next way we're going to look at factoring is, again, or not factoring, the next way we're going to look at evaluating limits is by rationalizing the numerator. Okay, so rationalizing the numerator. So I have the limit as x approaches 0 of the square root of x plus 1 minus 1 over x. Let's try plugging in 0. If you look, I'm going to get 0 plus 1, which is just 1 minus 1 over 0. Again, that's still indeterminate. Determinate. So now, here's what I'm going to do. And this only works with square roots. Only if you have a square root. So the limit as x approaches 0 of the square root of x plus 1 minus 1 over x. And we're going to rationalize the top. Because if I rationalize it, I can get rid of that nasty square root on top. So the square root of x plus 1 plus 1 over the square root of x plus 1 plus 1 again. Now, again, you have to remember, on top, we're going to be FOILing. Again, this is the limit as x approaches 0. Times square root of x plus 1 plus 1 all over x times square root of x plus 1 plus 1. Now, again, don't FOIL out the bottom. Let's just FOIL out the top. So we have the limit as x approaches 0 of, well, the square root, again, we're going to do FOIL on top here. All right, the square root of x plus 1 times the square root of x plus 1. That's just x plus 1. Okay. Outer, x plus square root of x plus 1 times 1 is positive square root x plus 1. Okay. Inner, negative 1 times the square root of x plus 1 is negative square root x plus 1. And negative 1 times 1 is negative 1. All over. Now, we're not going to FOIL, we're not going to distribute this bottom part out. It's just x times square root of x plus 1 plus 1. Now, let's see what we can cancel. Well, on the square root of x plus 1, you have negative and positive, so those can cancel, right? And then I have a positive one and a negative one, so that can cancel as well. Then I am just left with, and now I'm going to move over here, the limit as x approaches 0 of x over x times the square root of x plus 1 plus 1. Okay, again, those x's can cancel. So it is the limit as x approaches 0. Now, since those x's cancel, I'm left with fancy 1 on top. And it is the square root of x plus 1 plus 1. Now I can plug in my 0 and evaluate. So, it is 1 over the square root of 0 plus 1 plus 1. Well, that's just 1 over. Square root of 1 is just 1. 1 plus 1, which is 1 over 2. Okay. We're going to look at one more of those. These are fairly common. You'll get a couple examples of those for homework. I would expect one like this maybe to show up on a quiz. This time we are going to try the limit as x approaches 3 of the square root of x plus 1 minus 2 over x minus 3. Plug in direct substitution, I still get 0 over 0. That is indeterminate. So we are going to start by multiplying by the conjugate, which remember is the opposite. So if I have the square root of x plus 1 minus 2, I'm going to multiply by the square root of x plus 1 plus 2 over the square root of x plus 1 plus 2. Okay, so again I have the limit as x approaches 3 of the square root of x plus 1 minus 2 times the square root of x plus 1 plus 2 all over x minus 3 times the square root of x plus 1 plus 2. Again, don't FOIL out the bottom. Only FOIL out the numerators. So the limit as x approaches 3 is, again, I'm going to FOIL the top out, leave the bottom as it is. So square root of x plus 1 times square root of x plus 1 is x plus 1. Outer is just 2 root x plus 1, so plus 2 root x plus 1. Inner, negative 2 root x plus 1. Last, negative 2 times positive 2 is negative 4. All over. Now we're just going to write this as it is, don't FOIL it. So x minus 3 times the square root of x plus 1 plus 2. Again, my positive and negative cancel, and so I am left with the limit as x approaches 3 of, well, x plus 1 minus 4 is x minus 3, correct? X plus 1 minus 4 becomes x minus 3 all over x minus 3 times the square root of x plus 1 plus 2. And again, x minus 3 and x minus 3 will cancel. So I am just left with moving over here the limit as x approaches 3 of 1 over square root of x plus 1 plus 2. So the limit as x approaches 3 of 1 over the square root of 3 plus 1 plus 2. 3 plus 1 is 4. The square root of 4 is 2. So now that I have plugged it in, I no longer have my limit. So 1 plus 2 plus 2, so that is 1 over 4. That is my limit.